Hello friends, let me start next example. Determine the horizontal and vertical components of reaction at the point A, B and C of two-member frame. This is a two-member frame. You can see there are two members A, B and BC, and there are three supports A, B and C. Each is a pin support, so each support will give two support reactions. So we have find CKS reactions. Let me start. First, what we will do, we have to first draw free body diagram for this structure or for this frame. Let me draw here. This is point A, this is B and this is member BC. Here will be two reactions, that is one will be vertical and one will be horizontal. AY, this is vertical and horizontal is AX. Here will be one vertical, I will write BY vertical and one horizontal, that is BX. And at this point there will be equal and opposite forces because summation of forces at this point will be 0. So here will be BX in upward direction and this is BY vertical force and BX will be in opposite direction. At point C there will be one vertical force, that is CY, and one horizontal force, that is CX. And here is a uniform distributed load 3 kilonewton per meter. We will convert it into point load of equal magnitude, that is 3 into 2, that is 6 Newton. 6 kilonewton. 6 kilonewton, and this will be at center 1 meter. This distance will be 1 meter. And in member AB there is a load of 8 kilonewton. 8 kilonewton. And the slope is given also a 4, 3 and 5. Now let me start. First we will start from member BC and we will use this sign convention. If momentum will try to rotate beam in upward direction, we will treat it as positive, and if momentum will try to rotate beam in downward direction, we will treat as negative. And upward forces we will treat them as positive and downward forces as negative, and we will treat forces in X direction as positive and in this opposite direction we will take them as negative. So let me use these sign conventions. First we will take beam, this member BC. So we will take summation of momentum at point C will be 0. So I can write momentum is force into distance. So I can write because of this force I can write summation of momentum at point C equals to 0. So I can write by into distance. This distance is 2 meter. This bx is passing through point C, so it will be momentum due to this bx force will be 0 because distance is 0, and minus due to this force 6 kilonewton, 6 into distance, that is 1 meter, will be 0. And these two forces are also passing through the point C, so momentum will be due to these two forces will also be 0. You can check this force bx is trying to rotate beam in upward direction, so I treat it as positive, and this is trying to rotate beam in downward direction, I treat it as negative. So I can calculate by from this will come 3 kilonewton. Now I know by is 3 kilonewton, so now I can use this summation of forces in X direction or in vertical direction will be 0. So I can write by plus cy. This upward forces will be equal to downward forces equals to 6 kilonewton. Our by is 3, so I can write 3 plus cy equals to 6 kilonewton, which further implies cy comes out to be 3 kilonewton. So our cy is 3 kilonewton. Now let me move to next member, that is AB member. This is our AB member. I will write here. This is AY this is AX, here is BX, and here is BY, and there is 8 kilonewton force, 8 kilonewton, and this slope is 435. Now I will take summation of momentum at point A equals to 0. So I can write this force 8 kilonewton minus 8 kilonewton into distance. This distance is 2 meter. So I will write 8 into minus 8 into 2, and this will also minus by into this distance. This distance is 2 meter. This perpendicular distance from this. This is 2 plus bx into this distance. This is 1.5 meter. You can check here. This is 1.5 meter into 1.5, which further implies minus 6. This is 0 minus 16 minus by. We calculate by, which comes out to be 3 kilonewton. So this will come minus 6 plus bx into 1.5 equals to 0. So I can write 16 plus 6 divided by. So our bx comes out to be 14.66. So I will write here bx is 14.66. Now I have to calculate ay, ax, and this by. Now let me move to the next page. This is ay, this is ax, this is bx, and this is by. Here it was 8 kilonewton. 435. Now bx is 14.66, 14.66. And if we use this bx and cy, if in member this bc, we can write summation of forces in horizontal direction will be 0. So I can write bx minus cx equals to 0, which further implies bx is 14.66 minus cx equals to 0, which further implies cx will come 14.66. So our cx is 14.66. Now I have to find these forces ay, ax, and by. For this we can use summation of forces in vertical direction equals to 0. So I can write forces in vertical direction is ay, this in upward direction, so I will take this as positive, minus this is in downward direction by. Our by is 3 kilonewton. We find it earlier, 3 kilonewton. So I can write ay minus by, and due to this 8 kilonewton, it have two components, one vertical and one horizontal. I will write it is vertical component. It is in downward direction. I will write minus 8 cos theta. This will be cos theta, but cos theta is 4 by 5. Base by hypotenuse will be 0. So I can write ay minus by is 3 minus 8 into 4 by 5 equals to 0, which further implies 8 into 4. So our ay will come 9.4 kilonewton. I will write here ay is 9.4 kilonewton. Now I have to find ax, only ax. So I can, for this I can write summation of horizontal forces will be 0. So I can write horizontal forces. I will take this direction as positive. I can write ax, this as negative, minus bx, and this component, sine component of 8 kilonewton, that is plus 8 into this sine theta, that is 3 by 5, equals to 0, which further implies ax minus bx is 14.66 plus 24 by 5 equals to 0, that is ax will come 9.86 kilonewton. Hope you understood this.